This is lesson 6.5, elementary algebra applications. I'm not going to lie to you, these are story problems and they can be a little tricky. But let's go ahead and get through them. And again, with story problems, like I say, sometimes it takes longer for some of you to get these than for others, and that's okay. Some of you may never get story problems. My wife Jill can't do story problems to this day. But it's one of those things that you just keep practicing and practicing, and you start getting better and better at it. Doesn't necessarily mean you're going to get them, but if we just skip them, then you'll never get them. So at least this way you're getting a little bit of practice, and I'd like you to try some of these. So let's do example 1. We've got two numbers, and it says one of those numbers is twice the other. That means one of those numbers is big and one is little. So one is going to be small, and the other one, it says it's twice the small one, so this one is big. So there's our two numbers. The sum of their reciprocals is 9/2. So what is the reciprocal of x? 1 over x. What is the reciprocal of 2x? 1 over 2x. So the reciprocal just means that you're taking whatever you have here and flipping it over. Okay, so any number that isn't a fraction, you put it over 1 and it makes it into a fraction, and the reciprocal is it flipped over. Now it says that if we add those two reciprocals, so if we had 1 over x plus 1 over 2x, what happens? The sum of their reciprocals is 9/2. So that is our equation. Okay, so let's give ourselves a little bit of room, move this up, because what I have there in the box is all we really care about. Now we just have to add those. Alright, so what is the common denominator? Well, the common denominator is whatever we're missing in each one of these. So if you look at this one, what are we missing? We're missing a 2. And when we look at this one, we're not missing anything because we have a 2 and we have an x. What are we missing here? We're missing an x and an x. So I have a 2 over 2x plus 1 over 2x, because we didn't do anything to that one. And then I have 9x over 2x. So there's our common denominators. Now if we multiply the entire thing by the common denominator, then we have 2x times 2 over 2x plus 2x times 1 over 2x equals 2x times 9x over 2x. Alright, so let's cancel in red. And I have 2 plus 1 equals 9x, or 3 equals 9x. And divide by 3, divide by 3. Oh, I'm sorry, not 3. What am I thinking? I'm trying to get rid of the 9, so I divide by 9. And then 3 over 9 reduces to 1/3. That goes away. And that is our x right there. Now, what are they asking for? Find the two numbers. Well, that's only one of the numbers. The other number is 2x. So we have to take 1/3, which is our x, and multiply it by 2. So, or 2 over 1. So 2 times 1 is 2, 3 times 1 is 3, so our answer is 2/3 for our second number. So our one number is 1/3, our other number is 2/3, and that ends up being our answer there. And if we add 1/3 and 2/3 together, we get 1, but we got 1/3, and the other number is twice as large as 2/3. And remember, these, if we take the reciprocals and add them, we should get 9/2, and we find out that we do. That if we take 3 over 1 plus 3 over 2, the reciprocals of each of those, we will get our 9/2 up here. Okay, so I guess the key thing I want you to focus on is realizing that we had to find the common denominator. So I found the common denominator, which was 2x, and I multiplied the entire equation. And this works only when there's an equal sign. If this was just 1 over x plus 1 over 2x, you couldn't multiply the whole thing by the common denominator. Okay, only if there's an equal sign can you do that. All right, and the only reason we do that is that gets rid of the entire denominator. It makes it so there's no fractions there, and that makes it easier to solve. All right, so that's example 1. So example number 2, whenever we're dealing with boats up a river or people riding bikes or people running or that kind of thing, we use a cool little chart. So I am going to, let's see what it says. We've got a boat travels 30 miles up a river in the same amount of time it takes to travel 50 miles down the same river. If the current is 5 miles an hour, what's the speed of the boat in still water? So how fast is the boat going if it didn't have the current of the river either slowing it down or speeding it up? Alright, so let's do an up and a down. And the book has their example that does the same thing. And if you remember, when we're dealing with speed, we're looking at the formula d equals rt. The distance traveled equals how fast it's going, the rate, times the time. So we're going to put a d here, and an r there, and a t there. Okay, so we're going to fill in the blanks. A boat travels 30 miles up a river. That's its distance. In the same amount of time it takes to go 50 miles down the river. So we're going 50 miles down the river. If the current is 5 miles an hour, okay, so if the current, let's make a little river here, is going 5 miles per hour this way, and you're in your boat and you're going upriver. Okay, there's my boat. Put a sail on it. Alright, if we're going up a river, it is going at a certain speed up the river. But this 5 mile an hour, you're going against the current. So you're going 5 mile an hour slower because the river is pushing you the other way. So your speed is your speed in flat water minus 5. Now when you're turning around and going downstream, you're going the speed of the boat, plus you're going another 5 mile an hour because the current is pushing you downstream. And one of the things that you learn about your time is, if you've got this formula, in order to find the amount of time it takes, we're going to have to get rid of this r here. So we're going to divide both sides by r. In order to get rid of that, and so we can just find the time portion of that. And so the time is distance over the rate. So my time here is going to be 30 over x minus 5. In this one it's going to be 50 over x plus 5. Distance over the rate. Okay, so let's get rid of my drawing and some of my other junk here so that I can go ahead and do the work. Alright, so at this point, what do I know? I know that it says a boat travels 30 miles up a river in the same amount of time. So that means that the amount of time it takes to go up the river is the same amount of time it takes to go down the river, only we get to go further down the river because we're going faster. So my times are equal to each other, aren't they? Okay? Now, what I would suggest doing when you have two fractions that are equal to each other like that, I would suggest cross-multiplying rather than finding common denominators. The book is teaching you to find common denominators, but there's no sense in doing that if you don't have to. So that means we're going to multiply to distribute there. Okay. So let's go ahead and keep going with this. We'll move this up. Since this bottom equation is all we're really concerned with, I'm going to make my ink a little bit smaller so I can write smaller. Alright, so we've got an x here and an x here, and we need to get those together. So I'm going to get the smaller one and move it over to the bigger one side. So I'm going to subtract 30x from both sides, so that gets rid of that, and I have 150 equals 20x minus 250. I'm going to add 250 to both sides to get the 250 over here on the left, so that gives me 400 equals 20x, and so that gets rid of that. Divide by 20, divide by 20. So this gives me 20 equals x. Those cancel. 400 divided by 20 is 20. So x equals 20. And that gives me how fast my boat is going in still water, because when I look back up here to my original box here, that's what we are setting x equal to, because in going upstream it was the speed in still water minus 5 because it was going against the current, and here it was plus 5 since it's going with the current. So that's example number 2.